How you guys doing tonight? We are going to be, excuse me, we're going to be going over Chapter 2, definitions. Now, it's pretty much self-explanatory. That's all it is definitions. So I figure what we'll do is just hit some of the key definitions that I feel warrant discussion. If you have any that you come across in your studies that you want to talk about or you have question about, feel free to let me know. Give me the definition, and I'll be more than happy to explain that definition to you. So let's go ahead and get started. This video is going to be a little shaky. Hopefully not, but we'll see. We're going to start with accessible. Where applied to a fixture, connection, appliance, or equipment, accessible means having access thereto, but which first may require the removal of an access panel, door, or similar obstruction. So, in other words, let's say you have to get to a shutoff valve. That shutoff valve is nowhere to be seen because it's behind an access panel. So you open up the access panel and there is your valve. Therefore, it is accessible. It's the next one that is highlighted is readily accessible. That is having a direct access without the necessity of removing a panel, door, or similar obstruction. In other words, I got to shut this thing off. Where's the valve? Oh, there it is. Turn, shut off the valve. It's right there. There's no access door. There's nothing hiding it. It's plain view. So that is a readily accessible valve. Then you have an air brake. An air brake is the physical separation which may be a low inlet into the indirect waste receptor from the fixture, appliance, or device indirectly connected. So an air brake is a physical separation between an indirect waste line and the receptor itself. And that's not to be confused with an air gap. Okay? The air gap for drainage is the unobstructed vertical distance through the free atmosphere between the lowest opening from a pipe, plumbing fixture, appliance, or appurtenance conveying waste to the flood level rim of the receptor. So now you have an unobstructed vertical distance through the free atmosphere. So it's a little bit different than an air brake, okay? And then an air gap for water distribution is the unobstructed vertical distance through the free atmosphere between the lowest opening from a pipe or faucet conveying potable water to the flood level rim of a tank, vat, or fixture. And again, that is your unobstructed vertical distance, okay? Alternate water source. Non-potable or potable. I call it potable, so get used to potable, even though that's not the correct term. The correct term is potable. And that means drinking water, by the way. So the alternate water source is a non-potable source of water that includes but not limited to gray water, on-site treated non-potable water, rainwater, and reclaimed or recycled water. We're going to hit area drain. Sorry, excuse the mess. There you go. Area drain. A receptor designed to collect surface or storm water from an open area. So your area drain is just like a grate, okay? A circular grate, square grate, any kind of a grate that receives the discharge of rainwater, okay? Because it's out in an open area. That's your area drain. The authority having jurisdiction, all of what Chapter 1 was about. It's the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, installations, or procedures. The authority having jurisdiction shall be a federal, state, local, or other regional department, or an individual such as a plumbing official, mechanical official, labor department official, health department official, building official, or others having statutory authority. In the absence of statutory authority, the authority having jurisdiction may be some other responsible party. This definition shall include the authority having jurisdiction's duly authorized representative. So the authority having jurisdiction is the person or persons that set the rules and enforce the rules. So that is your authority, and their jurisdiction is the municipality. Okay. Backflow. Backflow is the flow of water or other liquids, mixtures, or substances into the distributing pipes of a potable supply of water from sources other than its intended source. See back pressure backflow and back siphonage. So in other words, a backflow is a reversal of flow. So, okay, you've got something coming in from the street, your potable water source. Let's say that you have some kind of a cross connection somewhere and you're siphoning everything out and the city water goes into a negative pressure where they're dropping their main line. Okay, so now you've got this buildup of contaminated water, say sitting in your laundry sink, okay, and you just finished washing off your paintbrushes or something, you're letting them soak, and you're running your water. But when you're running your water, you hook up a hose to the faucet of your laundry sink, and that hose is sitting inside the basin of the sink. So you've got this tub basin filled with paint water, and your hose is sitting in there because you have it connected to your faucet, and yet you're still running the water. All of a sudden, the pressure drops down to nothing, and the water is being drained out. Well, since there's no air brake, okay, which is the separation between your drinking water and a contaminated source, since there's no air brake and it's essentially going to siphon out that sink basin, creating contaminated water, and it's going to go all the way back to the city main and it's going to contaminate the city main. Backflow Preventer. It's a backflow prevention device, an assembly, or another method to prevent backflow into the potable water system. Your backflow preventer and everything that contains your backflow prevention, there are several different types, and that's all going to be mentioned in Chapter 6 when we get to domestic water. Your back pressure backflow. That is a backflow due to an increased pressure above the supply pressure, which may be due to pumps, boilers, gravity, or other sources of pressure. So you've got an active pressure in the water line of, say, 50, but you're pumping something in your yard using water, but you have the polarities reversed on the pump, and therefore you're actually pumping more pressure into your system. And as your pressure increases in your house, you're pumping everything out of your house back out into the street, therefore causing a back pressure backflow. These are all worst case scenarios, but that's pretty much what the code's based on, worst case scenario. Keep in mind, we are responsible for the health and safety of the masses. We provide the water, we provide clean water, and we also provide a place to dispose of waste and excrement. Back siphonage. Back siphonage is the flowing back of used, contaminated, or polluted water from a plumbing fixture or vessel into a water supply pipe due to a pressure less than atmospheric in such pipe. See also backflow. So like I was saying in backflow, if you have that tub, it's full of water, and the water pressure drops, that's going to suck out or siphon into the potable source and create your back siphonage. A backwater valve. That is a device installed in a drainage system to prevent reverse flow. So let's say your house sits below a manhole, and a sewage manhole. The sewer manhole isn't there for access. Obviously, you do use it for access to get into the sewer systems, but it's also there to be a form of overflow. Okay, so let's say your house is situated below the manhole, and if there ever is a sewage backup, guess who's getting that sewage backup? You are, because you are below the manhole. With that being said, the one thing you're going to want to put in is a backwater valve. And all it is a check valve. Okay, it prevents your flows coming this way. You put a backwater valve in right here. So as you flow out, it opens. The flap just kind of opens and everything goes out. However, so this is open, right? As the flow comes this way, it's going to hit this and it's going to close it. And therefore it's not going back into your house. How do you like that for the hand gestures, huh? We'll see how that turns out. So yeah, backwater valve is, it's essentially a check valve for a waste line. And then a bathroom. I figured it was something we should talk about because that's what we do, is we build bathrooms. It is a room equipped with a shower, bathtub, or combination bath and shower. So a bathroom is not a place that has just a water closet and a lavatory. Water closet being the toilet, lavatory being the bathroom sink. Shift. I love this laptop. It allows me to do so much. Okay, a half bath. That is a room equipped with only a water closet and a lavatory. A bathroom group. Any combination of fixtures not to exceed one water closet, two lavatories, either one bathtub or one combination bath shower, and one shower, and may include a bidet and an emergency floor drain. So that's your bathroom group. This is something we see a lot more of, so it bears mentioning. A bottle filling station. It's a plumbing fixture connected to the potable water distribution system and sanitary drainage system that is designed and intended for filling personal use drinking water bottles or containers not less than 10 inches in height. Such fixtures can be separate from or integral to a drinking fountain and can incorporate a water filter and a cooling system for chilling the drinking water. Those are getting put in more and more, but the code has certain requirements for those, and we'll get into those in another chapter. Okay, these are some of the terms that we went over in Plumbing 1, but it does bear repeating. The building drain. It's that part of the lowest piping of a drainage system that receives the discharge from soil, waste, and other drainage pipes inside the walls of the building and conveys to a building sewer beginning 2 feet outside the building wall. So the building drain extends to 2 feet outside the building, and then from there, the building sewer picks it up. And we'll talk about that in about three definitions, so don't worry about it. The building drain on sanitary is a building drain that conveys sewage only. Then you have the building drain storm, and that's a building drain that conveys storm water or another drainage, but no sewage. Then we have the building sewer, and that part of the horizontal piping of a drainage system that extends from the end of the building drain and that receives the discharge of the building drain and conveys it to a public sewer, private sewage disposal system, or another point of disposal. Then we have the building sewer combined, which is a building sewer that conveys both sewage and storm water or other drainage. Be careful, that's not allowed here, but it is still mentioned in this code book, and it's one of those rare instances where this code book kind of contradicts itself, so we'll get into that later. The building sewer sanitary, which is a building sewer that conveys sewage only. Building sewer storm, or building storm sewer, is a building sewer that conveys storm water or another drainage but no sewage. Then you have a building subdrain, and that's that portion of a drainage system that doesn't drain by gravity into the building sewer. And let's see, there we go. Certified backflow assembly tester, right here. A person who has shown competence to test and maintain backflow assemblies to the satisfaction of the authority having jurisdiction. So I've mentioned it a few times in several of my classes, and some of you haven't had me yet. So what a certified backflow assembly tester is somebody who puts in backflow prevention devices. Check that, my mistake. Not who puts them in, but he checks on them annually. A backflow prevention device has to be certified by a certified tester once a year or annually, sometimes more, okay? but at the very least annually. If it doesn't get certified, then fines are assessed, because we take backflow seriously, and all commercial buildings have to have a backflow prevention device. So every commercial building has to pay somebody to come out and test these things. You can go to Cuyamaca College and get yourself certified to become a backflow prevention tester or backflow assembly tester. I've been certified a couple of times. I rarely used it, so I let it lapse both times. Actually, no, I'm currently certified right now. So if you were to get certified, it takes 15 minutes to certify a backflow, and you get paid roughly 75 bucks each backflow device. So 15 minutes worth of work, 75 bucks. You figure what, you can get 2 done an hour maybe, or maybe 4 if they're all in one bank, and that's 300 bucks in 1 hour. So it's not a bad gig if you can get it. Cesspool, a lined excavation in the ground that receives the discharge of a drainage system or part thereof, so designed as to retain the organic matter and solids discharging therein, but permitting the liquids to seep through the bottom and sides. Let's put it this way: it's not something you want to fall into. Okay, rather nasty bit of business if you fall into that. And I don't think I have any more there, so we go over to this. Clear water waste. Cooling water and condensate drainage from refrigeration and air conditioning equipment, cooled condensate from steam heating systems, and cooled boiler blowdown water. So that's what clear water waste is. Combination temperature and pressure relief valve, a TMP valve. It's a relief valve that actuates when a set temperature pressure or both is reached. I can slow that down a little bit to make it sound a little more understandable. It is a relief valve that actuates when a set temperature or pressure or both is reached, also known as a TMP valve. Every water heater has to have a temperature and pressure relief valve. The conductor. This is one that doesn't get talked about very often, but it is a technical term, and we're going to talk about it. It is a pipe inside the building that conveys storm water from the roof to a storm drain, combined building sewer, or other approved point of disposal. So in other words, whatever we call in the building that we're working on, say like I'm going to be installing some piping that conveys stormwater. Well, guess what I call it? I call it the storm drain line. That's not what it is. It is actually the conductor. So what are you putting in today, Ben? Well, today I'm putting in the conductor line. So nobody uses that word, but the code book does, and you got to know what it means because we're going to go over it. Contamination. It's an impairment of the quality of potable water that creates an actual hazard to public health through poisoning or the spread of disease by sewage, industrial fluids, or waste, also defined as high hazard. Continuous vent. It's a vertical vent that is a continuation of the drain to which it connects. The continuous waste. This was actually a question on the final that I gave for Plumbing 1. Continuous waste is a drain connecting the compartments of a set of fixtures to a trap or connecting other permitted fixtures to a common trap. Quick sketch of a continuous waste. So here's a sink, dual basin sink, right? You can put a faucet in here if you want. Right? So this guy comes down and goes over and runs into the wall. This comes over and ties into here. That is a continuous waste. Copper alloy, which is right there. I'm bringing this one up because up until now it was called brass. So a copper alloy, brass, is a homogeneous mixture of two or more metals in which copper is the primary component, such as brass and bronze. So the code book used to call it brass, and then they went ahead and said, well, let's get really technical and call it what it is, which is a copper alloy. Critical level. The critical level marking on a backflow prevention device or vacuum breaker is a point conforming to approved standards and established by the testing lab, usually stamped on the device by the manufacturer, that determines the minimum elevation above the flood level rim of the fixture or receptor served at which the device may be installed. Where a backflow prevention device does not bear a critical level marking, the bottom of the vacuum breaker, combination valve, or the bottom of such approved device shall constitute the critical level. So the maximum, we'll just go off the maximum distance for a backflow device. The maximum distance for a backflow prevention device is 5 feet above grade, or 5 feet above finished floor. That is 5 feet to the critical level, okay, not to the bottom of the backflow device, but to the critical level. Cross connection. It's a connection or arrangement, physical or otherwise, between a potable water supply system and a plumbing fixture or a tank, receptor, equipment, or device through which it may be possible for non-potable, used, unclean, polluted, and contaminated water or other substances to enter into a part of such potable water system under any condition. So essentially a cross connection is you're connecting potable water to sewer water, and that ain't good. The department having jurisdiction, right there. The authority having jurisdiction, including any other law enforcement agency affected by a provision of this code, whether such agency is specifically named or not. Design flood elevation. The elevation of the design flood, including wave height relative to the datum specified on the community's legally designated flood hazard map. In areas designated as Zone AO, the design flood elevation is the elevation of the highest existing grade of the building's perimeter plus the depth number in feet specified on the flood hazard map. In areas designated as Zone AO, where a depth number is not specified on the map, the depth number is taken as being equal to 2 feet. I bring that up because there are some things that we have to do in San Diego where we are considered in a flood zone. One that I can think of off the top of my head is Mission Beach. Every single time it rains, Mission Beach floods. I can remember seeing a picture in the Union Tribune back when they actually still printed the paper of a picture of a guy kayaking down Mission Boulevard. So that is considered a flood area, you know, high tide and all that good stuff. So the next one we're going to go ahead and talk about is direct vent appliances. That is an appliance constructed and installed so that all air for combustion is derived directly from the outdoors and all flue gases are discharged to the outdoors. So a direct vent appliance has its own set of air intake and outtake in order for the burner assembly to actually burn. Okay? F rating. That's the grade you get when you don't participate. No, the F rating is the time period that the penetration fire stop system limits the spread of fire through the penetration where tested in accordance with those standards right there, ASTM, E814, and UL 1479. That has to do with fire rating and going through a fire rated wall. We have to deal with that, and there's a whole chapter in our code book for that. Fixture unit. It's a quantity in terms of which the load producing effects on the plumbing system of different kinds of plumbing fixtures are expressed on some arbitrarily chosen scale. I find that humorous that we are dictated by an arbitrarily chosen scale for all sizing parameters in our code. There's actually a little bit of science to it, but I just find that funny. Essentially, a fixture unit is the value you place on a fixture. A lavatory has one water fixture unit. A sink, like a kitchen sink, has a fixture unit value for water of 1.5. It also has a fixture unit value on drainage, so a DFU, drainage fixture unit value, of 2. So your water fixture unit value for a kitchen sink is 1.5, yet the drainage is 2.0, because your sizing calcs are different by each different system. So don't get them mixed up. Then we have the flood level rim, which we've talked about. That's the top edge of a receptor from which water will overflow. Okay? That's this sink. Back to the wonderful demonstration here. The flood level rim of this is right there. There's your flood level rim, top of the sink. So all the waste comes up and overflows. And that's your flood level rim. Yeah, okay, good. The fog disposal system. A grease interceptor that reduces non-petroleum fats, oils, and grease, or fog, in the effluent by separation, mass, and volume reduction. Grease interceptor. Okay? For the most part. Grade. Grade is the slope or fall of a line of pipe in reference to a horizontal plane. In drainage, it's usually expressed as the fall in a fraction of an inch or percentage of slope per foot of length of pipe. So the grade is the fall. Okay, and there's a couple of different formulas you can use to find grade, and I'll probably be bringing that up in a surprise quiz sometime throughout the semester for you to work on. A gravity grease interceptor. Really quick, the grade has a formula. So you have this distance here, so we'll call that D1. And then you have this distance here, call that D2. Sorry. So here's your waste pipe coming through, right? This is your grade, or your finished surface. Okay? And your pipe, which is here, is running at an angle. So you have a distance of R. So the formula would be D2 minus D1 over R is equal to your grade, or percentage of fall. And in most cases, it's 1/4 of an inch per foot. Gravity grease interceptor. A plumbing appurtenance or appliance that is installed in a sanitary drainage system to intercept non-petroleum fats, oils, and greases from a wastewater discharge and is identified by volume, 30-minute retention time, baffles, not less than 2 compartments, a total volume of not less than 300 gallons, and gravity separation. These interceptors comply with the requirements of Chapter 10 or are designed by a registered design professional. A gravity grease interceptors are generally installed outside. So that's a gravity grease interceptor. Then we have gray water. Gray water is the untreated wastewater that has not come into contact with toilet waste, kitchen sink waste, dishwasher waste, or similarly contaminated sources. Gray water includes wastewater from bathtubs, showers, lavatories, clothes washers, and laundry tubs, also known as gray water, and gray water, all spelled differently, of course. A grease interceptor. It's a plumbing appurtenance or appliance that is installed in a sanitary drainage system to intercept non-petroleum fats, oil, and greases from a wastewater discharge. Okay? So in other words, a gravity grease interceptor is the same as a regular grease interceptor, only that the gravity grease interceptor is a little more detailed. Okay? And we're going to get into another one in a second. Heat fusion weld joint. It is a joint used in some thermoplastic systems to connect the pipe to fittings or pipe lengths directly to one another, or butt fusion. This method of joining pipe to fittings includes socket fusion, electrofusion, and saddle fusion. This method of welding involves the application of heat and pressure to the components, allowing them to fuse together, forming a bond between the pipe and the fitting. So your heat fusion weld joint is essentially what we do for polyethylene pipe, for gas piping. And if we can get our class back into a classroom environment, everybody's going to get certified in this stuff. You have to be certified to actually do that type of welding joint. Hot water. This has to be mentioned because really it's water at a temperature exceeding or equal to 120 degrees Fahrenheit. So if it's 119 degrees, by code, it's not hot. So stop complaining. Right? I'm sorry, 119 is just as hot as 120. The hydromechanical grease interceptor. It's a plumbing appurtenance or appliance that is installed in a sanitary drainage system to intercept non-petroleum fats, oil, and grease from a wastewater discharge and is identified by flow rate and separation and retention efficiency. The design incorporates air entrainment, hydromechanical separation, interior baffling, or barriers in combination or separately, and one of the following: external flow control with an air intake directly connected, external flow control without an air intake directly connected, without external flow control directly connected, without external flow control indirectly connected. These interceptors comply with the requirements of Table 1014.2.1. Hydromechanical grease interceptors are generally installed inside. So the hydromechanical grease interceptor, this one, is a smaller grease interceptor installed inside above ground. The gravity grease interceptor is one that is usually quite large, at least 300 gallons, right? And installed outside, typically underground. So that's the difference between the two. Indirect waste pipe. It is a pipe that does not connect directly to the drainage system but conveys liquid waste by discharging into a plumbing fixture, interceptor, or receptacle that is directly connected to the drainage system. Indirect waste pipe. Let's read it again. There's a whole chapter based on this. So it is a pipe that does not connect directly to the drainage system. So here we have a waste line that's not connecting to the drainage system. Instead, this thing drops its waste okay, into a plumbing fixture, interceptor, or receptacle that is directly connected to the drainage system. So you have pipe that's running across the ground and it drops into a floor sink, okay, which is like a large, deep floor drain. And that's connected to the wasteline. And the purpose of that is if there ever is a sewage backup, it's not going to contaminate the fixture, you know, because the sewage backup just goes out onto the floor. The indirect wasteline has that air break in there and an air gap of at least an inch. Depending on the size of the pipe, it's actually going to be larger. But that air gap that is installed by us protects the fixtures, and it's always in a commercial restaurant, something like that, you know, in the kitchen. That's usually where indirect waste is. In sanitary, it is a condition that is contrary to sanitary practice principles or is injurious to health. The conditions to which insanitary shall apply include the following: a trap that does not maintain a proper trap seal, an opening in a drainage system except where lawful that is not provided with an approved liquid sealed trap, a plumbing fixture or other waste discharging receptor or device that is not supplied with water sufficient to flush and maintain the fixture or receptor in a clean condition, a defective fixture, trap, pipe, or fitting, a trap, except where in this code exempted, directly connected to a drainage system, the seal of which is not protected against siphonage and back pressure by a vent pipe, a connection, cross connection, construction, or condition, temporarily or permanent, that would permit to make possible by any means whatsoever for an unapproved foreign matter to enter a water distribution system used for domestic purposes. And in the preceding enumeration of conditions to which the term insanitary shall apply, shall not preclude the application to that term to conditions that are, in fact, insanitary. Long one. Invert. The lowest portion of the inside of a horizontal pipe. A braised joint. A joint obtained by joining of metal parts with alloys that melt at temperatures exceeding 840 degrees, but less than the melting temperature of the parts to be joined. So a braised joint is anything exceeding 840 degrees. Look at the next one I have highlighted there, soldered joint. That is a joint obtained by the joining of metal parts with metallic mixtures or alloys that melt at a temperature up to and including 840 degrees. So braised joint is over 840, soldered is below. Lavatories in sets. 2 or 3 lavatories that are served by one trap. So I can have up to 3 lavs based on this definition. I can have 3 lavs served off of one P-trap. A leader is not somebody you follow so much as in this code book. It is an exterior vertical drainage pipe for conveying stormwater from roof or gutter drains. See also downspout. So the leader is the exterior vertical drainage pipe, not the interior, because that's the conductor. Okay? Let's go this way to lot. A lot is a single or individual parcel or area of land legally recorded or validated by other means acceptable to the authority having jurisdiction on which is situated a building or which is the site of any work regulated by this code, together with the yards, courts, and unoccupied spaces legally required for the building or works, and that is owned by or is in the lawful possession of the owner of the building or works. That's all one sentence. And essentially what that whole paragraph states is that a lot is a piece of property where you put your stuff on, a building, a yard, whatever you want. And it's yours legally within the confines of that, perimeter. That's a lot. A macerating toilet system. That is a system comprised of a sump with macerating pump and with connections for a water closet and other plumbing fixtures which is designed to accept, grind, and pump wastes to an approved point of discharge. So they have these water closets or toilets that get hooked up to a macerating pump. So it takes all your shit, takes all your toilet paper, takes everything that you put in that toilet, and it goes through a grinder. Turns it into a slurry. And then you pump that out, and you pump that into your regular waste system. We're going to do this term way down here on the bottom. May. That is a permissive term. Not a mandatory, permissive. You can do it, you don't have to do it, that kind of thing. Medical gas. A patient medical gas or medical support gas. I put that in there because we actually do the med gas systems. That's part of our plumbing scope of work. You have to be certified to do it, but we do the work nonetheless. Nuisance. Hold up. Mobile home park sewer. This guy. That part of the horizontal piping of a drainage system that begins 2 feet downstream from the last mobile home site and conveys it to a public sewer, private sewage disposal system, or other point of disposal. So a mobile home park sewer technically doesn't start until it's 2 feet downstream of the last mobile home site. Okay, everything upstream from that is not considered sewer. It's technically your mobile home park drainage system. Now let's get to the nuisance down here. Includes, but is not limited to, a public nuisance known at common law or in equity jurisprudence, where work regulated by this code is dangerous to human life or is detrimental to health and property, an inadequate or unsafe water supply or sewage disposal system. That is a nuisance. This is where it starts to really pick up and get a lot easier, because I don't think we do anything until pollution. This guy. And again, if you see something while you're going through the definitions in the code book, feel free to ask the question, can you clarify this definition? You can always ask me that. Go onto the Canvas and just submit a message to me and get me the question, and I'll be more than happy to answer it in the next Zoom meeting or lecture on YouTube. Pollution. An impairment of the quality of the potable water to the degree that does not create a hazard to public health, but which does adversely and unreasonably affect the aesthetic qualities of such potable water for domestic use, also defined as a low hazard. Down here, pressure. The normal force exerted by a homogeneous liquid or gas per unit of area on the wall of the container. The residual pressure is the pressure available at the fixture or water outlet after allowance is made for pressure drop due to friction loss, head, meter, and other losses in the system during maximum demand periods. So let's say you have street pressure of 80 psi and you want to know what your residual pressure is. So outside in the street, you're at 80 psi. Let's say your furthest fixture at the top is 60 feet up in the air, and we'll do everything based on chapter 6 of the code, which is water. We'll decrease our pressure 0.5 pound per foot of elevation. Okay, so at 60 feet, I'm dropping half a pound of pressure, so that means I dropped 30 pounds of pressure just to get up to the top fixture. So 80 minus 30 is 50. So right now I've got 50 pounds of static pressure, which is the pressure existing without any flow, which is the next one right here. So up at that top fixture, I don't have 80 psi at the street. I mean, I have 80 psi at the street, but I don't have that up on the top floor. I'm 60 feet up in the air, which means I'm losing 30 pounds of pressure. That fixture is operating at 50 pounds of pressure, static. I turn on that fixture, which requires 15 pounds of pressure to operate. That means instead of operating at 50 pounds, I have a residual pressure once my fixture is on of 35 pounds of pressure, which is the residual pressure. I hope that made sense. Private or private use applies to a plumbing fixture in a residence and apartment, to private bathrooms in hotels and hospitals, and to restrooms in commercial establishments where the fixtures are intended for the use of a family or an individual. That's private use. Scroll down to public or public use. Applies to plumbing fixtures that are not defined as private or private use. So anything that's not private or private use is public or public use. So let's read private use again. Applies to the plumbing fixture in a residence and an apartment, a private bathroom in a hotel and a hospital, and to the restrooms in commercial establishments where the fixtures are intended for the use of a family or an individual. So if I'm in a bathroom in a hotel, or a private bathroom in a hotel, so I'm in my hotel room, that's considered private because it's for me, right? What about a hospital bed? Well, if I'm in the hospital and I have a hospital room, that bathroom that's in that hospital room, it's designated mine at that point, right? Restrooms in a commercial establishment where the fixtures are intended for the use of a family or an individual. Well, if it's intended for the use of a family, like a family restroom, to sit there and clean the kid, that's considered private, right? So even in like the airport where you have the men's room and the women's room, anymore it's debatable, but there's always that one family room that is considered private. Okay, so receptor. Receptor is an approved plumbing fixture or device of such material, shape, and capacity as to adequately receive the discharge from indirect waste pipe, so constructed and located as to be readily cleaned. An example of a receptor: floor sink. Reclaimed water. Non-potable water provided by a water or wastewater utility that, as a result of tertiary treatment of domestic wastewater, meets the requirements of public health authority having jurisdiction for its intended uses. One of the largest reclaimed water facilities and the oldest reclaimed water facility, one of the oldest, is the Santee Lakes Water Reclamation Facility. That place has been around since the 60s, and nothing much has changed there except for the fact that they're taking it the next step and turning that reclaimed water into potable water. It's a fascinating process, and again, one of those things that we will do if we ever get back to class. A relief vent. That is a vent, the primary function of which is to provide circulation of air between drainage and vent systems, or to act as an auxiliary vent on a specially designed system. A roof drain. That is the drain installed to receive water collecting on the surface of a roof and to discharge it into a leader, downspout, or conductor. So the roof drain is the actual drain body that's up on the roof. Makes sense, right? We're almost done. We're almost there. Almost there. I'd say if about this time, I'd say, okay, it's break time. But right now, I'll say, hey, you got to take a break, pause it, come back after you're done with your break, and we'll resume. SDR, an abbreviation for Standard Dimensional Ratio, which is the specific ratio of the average specified outside diameter to the minimum wall thickness for the outside controlled diameter plastic pipe. It's just a method of measuring wall thickness of piping. So that's what SDR is. Then we'll come down to sewage pump. Yeah, we'll come down just a little bit more. Sewage pump. A permanently installed mechanical device other than an ejector for removing sewage or liquid waste from a sump. And we're going to talk about a sump right here. But let's do the other ones first. Shall. Shall indicates a mandatory requirement. May is a permissive term. Shall is it ain't permissive, it is you got to do it. Shielded coupling is an approved elastomeric sealing gasket with an approved outer shield and a tightening mechanism. In other words, it's a no-hub band. That's what a shielded coupling is. It is a no-hub band. When we get into chapter 3, I'm going to show you something, if I can get everything set up right, that irritates the heck out of me when it comes to Fernco's and shielded couplings. Should indicates a recommendation or that which is advised but not required. Slip joint, an adjustable tubing connection consisting of a compression nut, a friction ring, and a compression washer, designed to fit a threaded adapter fitting or a standard taper pipe thread. So your slip joint is something that goes underneath all of this. This is all tubing. All of this is connected using slip joints. So the pipe goes inside, the little nut and the ferrule and the washer and everything, it's all inside here. That's where a slip joint sits. There are a couple other cases where the slip joint's used somewhere else, but for the most part, that's where your slip joint's going to be. The sump. So now we're going back to this sewage pump, right? We got a pump. Where's the pump sit? Pump sits inside a sump. The sump is an approved tank or pit that receives sewage or liquid waste and which is located below the normal grade of gravity system, which must be emptied by a mechanical means, hence the sewage pump. And that's only put in places where you cannot gravity feed the city sewer. You have your line lower than that. Tailpiece. It's the pipe or tubing that connects the outlet of a plumbing fixture to the trap. Okay? Trap. A fitting or device so designed and constructed as to provide, where properly vented, a liquid seal that will prevent the back passage of air without materially affecting the flow of sewage or wastewater through it. So we all know what a trap is. The trap seal is typically 2 to 4 inches, and it goes from the, we'll talk about that in a second, sorry. Trap arm. Those portions of a fixture drain between a trap and the vent, so that's the horizontal part that goes from the crown weir all the way to the vent opening. That's part of your trap arm. A trap primer. A device and system of piping that maintains a water seal in a remote trap. The trap seal is the vertical distance between the crown weir and the top dip of the trap. And that's that 2 to 4 inches that I was just talking about. So your crown weir is the lowest point in the cross section of a horizontal waterway at the exit of the trap. So, once again, breaking out a drawing real quick. Crown weir, trap arm, there. Trap seal goes from here to here. There's your trap seal right there. Even though this is all liquid as well, the trap seal is just this part right here, which goes from the crown weir to the top dip of your trap. Top dip of the trap. It's the highest point in the internal cross section of the trap at the lowest part of the bend, inverted for siphon. By contrast, the bottom dip is the lowest point in the internal cross section. So that's that. We're not getting there yet. We're over here. Wet vent is a vent that also serves as a drain. A perfect example of a wet vent, a classic example of a wet vent, is, that's a water closet, okay? And let's say that water closet ties into a waistline, right? So this is your vent coming up. What is typically next to a water closet? A lav, right? So you can actually tap into the vent side you can tap into the vent of your lav, can run your waste over this way and drop down. This portion right here is your wet vent. From the drainage discharge to the actual drainage part here. So all of this vented portion for your water closet is the wet vented portion. We get more into that when we get to chapter 9. Yoke vent. A yoke vent is a pipe connecting upward from soil or waste stack to a vent stack to prevent pressure changes in the stack. Draw a quick one of that too. So you have vent pipe, right? And let's say you have a waste stack right here, and this is your vent stack. Every certain amount of floors you have to so there's your floor. Every X amount of floors, and I'm not going to get specific into it yet because we're going to go over it when we get into venting in chapter 9. But every X amount of floors, you're going to have to come up like this and tie it in. So your vents are going up, right? The airflow goes up and your waste goes down. Let's say you got 20 floors, right? And that's nothing but a waste stack coming down. Well, in 20 floors, all that volume is going to create a solid plug. So you have pipe and the waste comes down. And the waste will always come down and gravitate towards the edge of the pipe. It never flows down the middle. However, if you're coming down and you start to build up more and more volume, that speed and velocity coming down a vertical starts to separate off. And as it separates off, the liquid starts to go into the middle. And as it does so, it starts to slow down that air movement because you need air movement to have something fall down. Without that air movement, like you put your thumb on a straw, like if this is a straw and I put my thumb on that. I can pull it up. I have a straw full of soda. I pull that off and the soda comes out. That's what this is. This is pulling your thumb off that straw. Okay, this gives you that air. This makes this not happen. So that is your yoke vent. And as you can see, we are done with definitions for this code book. The next video we get into will be chapter 3, and I will see you guys then.